Hi guys, we've got a pretty tricky probability question for you today which involves the normal distribution. Now this forms the last part of a four-part question, but the first three parts to solve this one are unnecessary. Now let's have a look at it. We've got Rebecca also sells oranges. So obviously in the previous parts she sold something else as well. The weights of these oranges are also normally distributed. It is known that 5% of the oranges weigh less than 153 grams while 12% of the oranges weigh more than 210. Determine the mean and standard deviation of the weights of the oranges. Okay, so let's just write down what we have first. So we know that the probability that one of these oranges, let's just call the probability of X, is going to be less than 153 grams, is going to equal 5% or 0.05. Cool. And we also know that 12% of the oranges weigh more than 210. So what we can say is the probability that X is greater than 210 is equal to 0.12. Cool, so what we're going to do is we're just going to get a quick visualization on what these particular probabilities look like on a normal distribution. Okay, so what we have is the visualization of the normal distributions, each with their respective probabilities. So we know that the blue part here is equal to an area of 0.05, and this orange part has an area of 0.12. Now what we have to do, guys, is we have to find the relevant z-scores which go with each of these particular probabilities. Now you can use this on your calculators or you can use a stats tables book. But what I'm going to do for you guys is I'm going to write down what each of these are. So if we have a probability approaching from the left-hand side or negative infinity up to a particular point, which is equal to 5%, the relevant z-score is negative 1.6449. Now that's the amount of standard deviations away from the mean. So what we have on this one as well is we have a z-score is equal to 1.1750 to 4 decimal places. Now as you can see, this is negative because the cutoff for the probability is below the mean. This is positive, i.e. the cutoff for the probability is above the mean. Cool. So now guys, what we're going to use next is we're going to use a formula for calculating z-scores to set up a simultaneous equation. Now I'm just going to write it up here. We have the z-score is equal to the actual score, we'll call it x, minus the mean divided by the standard deviation. So what we're going to do is we're going to substitute all of the information that we know into this formula, and we're going to come out with two unknowns. We're going to come out with the unknown of the mean and the standard deviation. So what we're going to do is we're going to submit this one into this formula where we have negative 1.6449 is equal to the score. Now the score for this one is 153 minus the mean, which we don't know, divided by the standard deviation, which we also don't know. Now for this one, we have exactly the same. We're going to have 1.1750 is equal to the score, 210, subtract the mean, divided by the standard deviation. Again, we don't know the mean or the standard deviation. Now, if you're using calculators that you can program to give you these z-scores, I'm assuming that the calculators will be able to do simultaneous equations, and from here you'll be able to simultaneously solve this using the calculator. If not, we'll just quickly go through the algebra that's required to solve it, but I'm going to need some space to start with. Okay guys, so what we're going to do with each of these equations is I'm going to take the standard deviation over to the left-hand side, so they're both in terms of just the mean. So for this one, the standard deviation will go to the left, and this z-score will go in the denominator of the fraction. And the same with this one, I'm going to move the standard deviation to the left, and I'm going to move the z-score into the denominator. Cool. Now what we can do is, because both of these are in terms of the standard deviation, I can make them equal to each other. So I'm going to get both of these and join them together. So I'm going to have 153 subtract the mean on negative 1.6449 is equal to 210 subtract the mean divided by 1.1750. Cool, so what I'm going to do is I'm going to take the denominators, each to their equivalent side. So this one here is going to go up to there, and this one here is going to go up to there. And once I've multiplied all of that through, I'm going to get 179.775, subtract 1.1750 times the mean, which is equal to negative 345.429 plus 1.6449 times the mean. Cool, so what I'm going to do is I'm going to take this 345 to the left, and I'm going to take this 1.1750 times the mean to the right. Now let's just give ourselves some room, so I'm going to stick this up here. And what I have left remaining is 525.204 is equal to 2.8199 times the mean. So obviously the mean is going to be equal to 525.204 divided by 2.8199, which is equal to 186.25. Cool. So for now we have the mean. To find the standard deviation is relatively easy. I can just stick it into each one of these formulas. So I can say that, I'll put it in a different color. The standard deviation is going to be equal to 210 minus the mean that I've just figured out, divided by the z-score, which makes the standard deviation equal to 20.21, and that's going to be in grams, as well as the mean is also in grams. So there's our mean, 186.25, and there's our standard deviation, 20.21. Okay guys, let's just recap how we got a mean orange weight of 186.25 grams and a standard deviation in that weight of 20.21 grams. So the first thing we did, guys, is after reading the question, we wrote down or codified what the information that was contained in the question was. So we wrote down the probability that an orange being less than 153 grams is 5%, and a probability of an orange being greater than 210 grams is 12%. Each of these percentages, probabilities, on a normal distribution has an associated z-score. So what we did is we found each of their associated z-scores. 5% when we're evaluating it from the left has an associated z-score of negative 1.6449, and a 12% probability when we're evaluating it from the right has a z-score of 1.1750. What we then did is we put the z-score along with the boundary condition of 153 or 210 into two separate z-score formulas, which we were then able to solve simultaneously using a little bit of algebra. And after we did that, as long as we don't make any mistakes, the answer will just pop out as being 186.25 and 20.21 grams. So, thanks guys for watching this video. If you have any problems or questions about this particular problem, please leave them in the comments section below. Alternatively, if you have any problems that you think would make good videos, also leave them in the comments section below. I'm always looking for new ideas. But guys, if you did enjoy this video, please give it a like or a thumbs up, whatever you want to call it, and subscribe to my channel. I try and put out new videos all the time. And just remember, guys, there is no silver bullet with solving maths problems like this. You've just got to keep bashing your head against the wall and have faith that the wall will eventually fall down and you will eventually figure out how it's going to work. But yeah, just practice, practice, practice. With problems like these, if you have any problems, just look on YouTube. They always have solutions to particular complicated mathematical problems. But until next time, just keep enjoying your maths, and I'll see you soon.